Okay, so we're going to pick up from where we left off yesterday on Monday. I'm going to ask that you find the x-intercepts of a quadratic by graphing using that zero product property. So again, make sure you have your Desmos out, your notes out, and this should take us about 10 minutes is the goal. So yesterday we talked about the difference on how to find these zeros. That's the same thing as solving. This word zeros means the same thing as solving. So if I see the words zeros, roots, x-intercepts, they all mean to solve. Ooh, I don't think that's going to get on my screen. They all mean to solve. That's on my screen. Ooh, but you can't see that very well. Well, good luck with that. It all means to solve. All right. So I'm going to solve exactly what we did yesterday. I'm going to set this equal to 0. I'm going to undo it. And I'm going to be left with x equals -4. Some of you can do that in your head. Great. Some of you can't. If you cannot, please make sure you are using these tools in which to solve that you all have, mind you. X equals 3. If you have questions, write them down, and then I can answer them tomorrow. I know it's hard to see with the glare. I'm giving it a try. We'll find out what happens. All right. The next one, and then it says, let's graph it and see what happens. So go into your Desmos, and you're going to graph it without the equals 0. So hit pause, go ahead and graph it without this part, and see what happens to your graph. All right, so I would like you to please take this wonderful looking expression, it's an equation because it's an equal sign, and put this into Desmos and tell me what happens. I'm going to give you a few moments to type it into Desmos. We'll get a graph, see what happens. Okay, by now, you should have been able to get this into Desmos. And you should have come up with, apparently not that graph. These answers, the x-intercepts of the quadratic function, we'll call them the zeros or the roots. You should have come up with this. Notice that this 2 had no influence on this because this -7 is the opposite of this 7. -5 is the opposite of +5. So that 2 had nothing to do with this. So that means we're going to use some math, and we're going to make sure that I graphed it right, that I did everything I needed to. I'm going to set this equal to 0. I have x equals -7. Hey, that's what this is, -7. This one I'm going to set equal to 0 as well. And subtract 5 from both sides. X equals -5. Hey, look at that, -5. So remember that we are looking for these to equal 0. This to equal 0. Hey, look, this equals 0. This equals 0. So keep that in mind. Press pause if you need to in order to take some notes. Let's look at another one. Please put this into Desmos. I hope you got this graph to find the answers. Well, look at that. -1.3333, 0 and -0.5. 0. I'm going to make sure that these answers are correct and that I put it into Desmos correctly. I'm going to start here only because it's shorter than the other one. So this says -0.5 in case you didn't put it into Desmos. And it's telling me that x equals this. So let me put this in for here this in for here, and I'm going to solve. X equals negative 0.5. So I'm going to say 2x plus 1 and 3x plus 4 equals 0. Instead of this x and there being multiplied, put in negative 0.5. Sorry, it's not very big. I didn't give myself any space. Here, I'm multiplying by negative 0.5 also. 2 times negative 0.5 is negative 1 plus 1 equals 0. 3 times negative 0.5, because this is order operations, negative 1.5 plus 4 yields me 2.5. And remember, when they look like this, it's called multiplying. 0 times anything is 0. So check. This is a good solution. This answer, because this equals 0, this answer right here is a good solution. I would take negative 0.5. I'm going to leave it up there because it could also be you could write it in fraction form, and I'll show you that in a second. I'm going to take this one here and substitute that in and see what happens. So notice that this negative 1.333333, it does not matter if you, am I still on my screen? Yes, okay. It does not matter if I choose 1 3, 5 3s, 2 3s, that is 110% irrelevant. I'm just going to put this in there and see what happens. I'm going to do all of those 3s that I was given. So I'm hopeful that x will equal negative 1.333, because that's what this says. I'll multiply by negative 1.33. Negative 133 point, oh, I need 3 of them. 2 times 1, negative 2.666 plus 1. That's going to be negative 1.666. So let's hope this equals 0. That's the goal, because this one equaled 0 last time. Not this one equals 0. I'm going to get negative 3.999 plus 4. Well, if I put this into Desmos, ooh, that was sloppy, sorry, because I wasn't looking. I'm going to come out with 0.001. That's not 0. If this doesn't equal 0 or this doesn't equal 0, that answer, not going to work. So I can't use that. I have to solve. I have to set each term, each polynomial equal to 0. Ready? That's what I'm going to do. So this black one, he did not work. So I'm going to do this one in purple and this one in black. I'm going to do 2x plus 1. I'm going to set it equal to 0, and I'm going to solve. 2x equals negative 1. Divide by 2, divide by 2. X equals negative 1/2. So that's this here. This could be or negative 1/2. I would prefer the fraction. I see it better. I know that you know what you're talking about. But if you have a terminating decimal, that means it stops. It does not repeat. You can use it. That's okay. If the decimal goes on and on and on and on, you cannot use it. You can't, because it's not accurate. So please keep that in mind. Terminating, that means it stops. You can use it. If it goes on and on and repeats and repeats and repeats and repeats, you can't use it. Sorry, because it doesn't work. I'm going to take my other fancy dancy looking thing there, 3x plus 4 equals 0. I'm going to subtract 4 from both sides. 3x equals negative 4. I'm going to divide by 3, divide by 3. X equals negative 4/3. Or negative 1 1/3. But I would prefer this answer. It's easier for me to understand. This is fine. Prefer this answer, please. and it's less work. So if I put this into a calculator, if you put this into Desmos, -4 divided by 3, it's going to spit this out, -1.3333333333. That's because it's a continuing decimal. It goes on forever because it's out of thirds. So I won't take this as an answer. I will take -4 thirds only. So please be careful with your decimals and what it is that you are solving for. If you get a repeating decimal, 0.333, 0.625, 625, 625, can't use it. You have to find the fraction. If it terminates, if it stops, 0.25, that stops. 0.2, that stops. If it's a terminating decimal, I will take it. But if it's not, make sure you're doing the work. So let's look at another problem. Take a moment to catch up and press pause. I don't know. Oh, I'm moving forward. All right, so here we are back to those directions. Step 1, set it equal to 0. Well, does that equal 0? I don't think so. It equals 2, so I got to make it equal 0. So in order to make it equal 0, I'm going to, it needs to equal 0. What do you think I should do? I hope you said subtract 2. But if I subtract 2 from one side, I must do it to the other side. But if the question is, where do I subtract it from? What do you think? Do you think I should subtract a constant 2 from a variable squared, a single variable, or another constant? Have a thought. If you said the constant, you would be correct. The reason you cannot subtract from here is because this is a p squared. There's no p here. No p, no p, can't put them together. And you do know that about like terms. I'm going to get 6 here, and then I'm just going to rewrite my equation. P squared minus 5p plus 6 equals 0. All right, step 1's done. Check. Now I need a factor. All right. P squared minus 5p plus 6 equals 0. I would make sure that you try this independently. Press pause and try to factor this. You are going to find that a times c is 6. Factors of 6 are 1 and 6. So I'm going to write them down. Granted, this makes 5. 1 and 6 make 5, right, if I subtract them. This also makes 5 if I add them. So it has to multiply to a positive 6 and add or subtract to a negative 5. These, no matter how I do it, cannot make that. So if I said 6 minus 1, yes, I get 5. I need negative 5. So if I said negative 6 plus 1, I get negative 5. That's true. But if I multiply a negative and a positive, will I get a positive 6? The answer is no way. So I can't use those. So this must be a negative 2 minus 3 equals negative 5. When I multiply two negatives together, I get a positive. It is negative 2p minus 3p plus 6. I'm bringing down those extra terms, so this piece has never changed. We're factoring. I'm going to factor the left side. I'm pulling a p out, p. I'm left with p minus 2. Remember, this binomial must match this binomial, right? And I say to myself, self, what is 6 divided by negative 2? Go to your Desmos and find out. Don't you dare guess, because you guys and your negatives and me and my negatives, we all kind of stink. So think about what is positive 6 divided by negative 2. Use your Desmos to find out. I hope you got negative 3. So be careful about your negative signs. So remember, these come together, p minus 3. And then I'm left with this guy here, they're a GCF. And the whole thing itself still equals 0. So I have factored completely. Check. Now I need to solve for those x-intercepts. Let me just do it the right color. P minus 2 equals 0. I'm going to add 2 to both sides. Add 2 to both sides. P equals 2. Right? This is P minus 3 equals 0. I'm going to add 3 to both sides. P equals 3. These are my final answers when I'm solving. If I put it into Desmos, I get the same thing. But remember, if there's a decimal, you're kind of out of luck. So you definitely need to know how to do this. I have now solved for my x-intercepts. Check. Take a moment and make sure that you're on the same page and you're getting what's going on. I am here at lunch today, so please make sure that you come in at lunch if you have questions. The test is Thursday. So if I graphed that, this is what I ended up with. Let me erase this so we can all see it. I'm not going to have you get into Desmos and do it because I put it up here. So if I graph this, notice it's at 2 and 3. Hey, 2 and 3. I know it's a little sloppy, but that's a 2. These are awesome skills. And 3. So I factored it appropriately. Yay, me. Super excited, obviously. All right, does this equal 0? Have a thought. It sure doesn't equal 0, it equals 4. So I have to undo that 4. How do I undo this positive 4? Well, I have to subtract it from both sides. Is there a variable here? Nope, those don't match. How about this one? Nope, those don't match. How about this? Oh yeah, they sure do. Make sure you use Desmos for those ugly negatives. I'm going to tell you that it's negative 20. Then I rewrite my equation. And there I am. Now I have step 1 all done. Now I'm going to factor. I'm going to rewrite it over here just because I'm out of space, but you do not have to rewrite it. I need all the factors of 20 that add, 1 times 20 that add to 1. And I know that 20 has 1, 20, 2, 10, 4, and 5. And these are the only ones that add or subtract to 1. I have to get to positive 1, so it's going to be 5x minus 4x. I bring down the rest of my stuff, and that 5x is positive. I'm going to factor the left side. Taking out the x because they both share 1. X plus 5. I'm going to factor the right side. Oh, I don't know what to take out. Oh, I hate that part. So I'm going to write the binomial because they have to match. And I say to myself, negative 20 divided by 5. I put it into Desmos. Negative 20 divided by 5 will pump out negative 4. Now I can write my binomials. I'm going to do this one, x minus 4. And then I'm going to do this one, x plus 5. All equals 0. Because remember, I'm still solving. So I'm going to say x minus 4 equals 0. I'm going to add 4 to both sides. X equals 4. Yay! X plus 5 equals 0. I'm going to subtract 5 from both sides. X equals negative 5. Man alive. I hope that's right. Let's see. I think I got a Desmos picture up. Let's find out. Please take a moment to write anything down that you may need. All right, here we go. I graphed it. And hey, look at that, -5 and +4. Hot dog, I got -5 and +4 and -5. Go, Miss Stoddard. Pretty proud of myself. There are some other examples on here that we are not going to get time for. So we are going to fast forward through a few of them, and you are going to help me with the last answer, the last part of this. So we're not going to look at these just due to time, but know that they exist out there and it won't be on the final. So I was going to ask you to decide if this needs to be solved for the variable or not. And how do you know? You were going to write on whiteboards, but we ran out of time, so you're going to just do it in the program that you're using or in your notebooks. We'll see. I think it's going to be on Edpuzzle, so you'll be able to answer there. To solve or not to solve, that is the question. Does this need to be solved? And how do we know? All right, ready? We can't solve this because there's no equal sign. So keep that in mind. I can factor it, but I cannot solve it. If I have no equal sign, I can't solve it. I can factor, yes, solve, no. All right, ready? What do you think? Can we solve or factor this? If you said factor only, you'd be correct. Because there's no equal sign. I can only factor it. No equal sign, I can only factor. Let's look at the next one. What do you think about this one? Solve or factor? I hope you said solve, because look, there's an equal sign. So now I need to know n equals something. It's going to have a value to it. What do you think about this? Solve or factor? I'm not asking how to do it. I'm just asking, what do you think I should do? Solve it or factor it? If you said solve it because there's an equal sign, you would be correct. Good job. Solve or factor? You have to factor only because there's no equal sign. Do you see an equal sign? I don't see an equal sign. So you would have to factor it only, not solve it. Solve or factor? Factor only. There's no equal sign. Factor only. Let's see, is there one more? Yes, there is. If you said factor, you would be incorrect. Solve, because there's an equal sign. I have to solve. I need a value, an answer for the b. All right, so I'm going to solve. Use either Desmos or factoring. You must use a fraction if needed from Desmos. So that's your job at this point in time to make that happen. I'm going to help you out. And you'll write the answers into Edpuzzle. What will these all solve? You need an answer. X equals something. Who knows what it is? X equals something. Who knows what it is? I have an A equals 1 term here. This is B equals -9. What does C equal? If you said 0, you would be correct. It's not there. It's just not there. So I could rewrite this ax squared minus 9x plus 0. What times 0 adds or subtracts to 9? Are all the factors of 0? Oh, shoot. There are no factors of 0. That means you need a GCF to come out of this bad boy. That is what you need to do, is take a GCF out and then solve from there. What about here? What do you think? I have an A term. A equals 9. Do I have a B term? Remember, it has to have one variable. Nope, no B term. I have a C term, -4. Let me see. Maybe this will work. 9 times -4 is -36. What are all the factors of 36 that could add to 0? Well, there's several factors of 36. 1 and 36, 2 and 18, 3 and 12, 4 and 9, and 6 and 6. Could this add or subtract to 0? No. Add or subtract to 0? Add or subtract to 0? Add or subtract to 0? Ooh, these can add or subtract to 0. This is factorable. When B is 0, it's factorable. It's when C is 0 that it's a struggle. Quite the struggle. So give that a go. That is your closure for today. As soon as you've typed your answers in and you've checked them that they're correct, you've substituted it back in and made sure they're correct, you may get your review packet from the sub or the support staff who's in class. Have a good day. Hope this worked.